what really we talk about, and so we should. We are carbon-based, the environment's carbon-based, and this is where we got our carbon from in the past, petroleum, and this is where we'll get it from in the future, which is biomass, and biomass is all around us. And don't believe all the nonsense about there ain't enough biomass to feed us. And 1% of the carbon nature turns over every day is enough to give us all the chemicals, materials, polymers, plastics you could possibly want in society, even with double the population. Nature, it does it all, We just have to be clever enough to be a little bit more resource efficient. If we reach the same resource efficiency as the pharmaceutical industry, we could do it, actually, ironically. We don't need to do that much. We know we can make all those things. We just have to learn to be a bit cleverer to avoid food-grade feedstocks. Of course, biofuels was a great learning for us in that respect. And we need to learn from the biofuels experience with biochemicals and biomaterials and bioplastics and so on for the future. Just a few examples of things we do. This is basically taking any type of food waste or bio waste and using something called supercritical carbon dioxide. Carbon dioxide is one of the 3 solvents that the EU classifies as natural, along with ethanol, or bioethanol to be precise, and water. So we use carbon dioxide that can be made a liquid, essentially, to extract various chemicals from biomass. Every plant on the planet has surface chemicals. You feel a leaf, you feel a tree, you're feeling chemicals on the surface. They are designed by nature to do all sorts of things like repel insects or attract insects, repel water or keep water, all sorts of different things depending on the plant, where they live and so on. You can extract those chemicals and they can be used for all sorts of things like cosmetics. We call them waxes. They're everywhere. And yet, every gram of wax we use in this country for cosmetics, for polishes, for all sorts of things, we import. Why on earth do we import all our waxes? They're all around us. So, things like that, we should be doing better. This is just the materials. I won't dwell on that one, showing the range of things you can make from using all sorts of wastes. There's a nice picture of a crab there. Crabs, crustaceans, are the source of the 2nd largest volume biomass in the world. After cellulose, the really big one, you've got something called chitin, which is basically what insects, including flies and crabs and all sorts of things, actually use to construct their shell. I'll tell you a funny story about, I'll mention later about our MSc course in green chemistry, which we get people from all over the world. It's great fun. A lot of Chinese. And we set them like business games, and we say, okay, come up with an idea that could actually make money, make economic sense in terms of green chemistry. And there was a Chinese guy a couple of years ago who came along and talked about crustaceans, talked about extracting chitin. And he said, actually, I've discovered flies are the biggest source of chitin on the planet. This amazing material that covers flies you can use for all sorts of things like contact lenses. So, okay, that sounds a good idea. So basically he set up this model, and the business model was all based around, you start off with 100 flies, and before you know it, you've got 1 billion flies, and so, you can produce all this chitin, absolutely fantastic. And after his presentation, everyone's really wowed about this, and one of the students in the back said, excuse me, how do you actually contain all these flies? And he looked him in the eye straight, and he said, these are Chinese flies, very obedient. And I thought, yeah, that's the spirit. Now, we heard about carpet tiles yesterday, so by pure chance, we are also working on carpet tiles for a rival company, so whose name it's there, sorry, Interface Floor, a local company who actually also make carpet tiles. They're the world's biggest, I believe, and they came to us about 5 years ago and said, we've got a waste problem. All our carpet tiles end up going into landfill because, as I guess you know by now, some of you anyway, you can't separate the components of the carpet tile at the end of life, so you can't use them again. They're stuck together to last, not to be separated. So we thought about this for a while, and the solution we decided, the best solution for us, we thought, was to actually change the adhesive technology to allow us to separate the components. So stop that and allow that. Now, we had to therefore work on different adhesives, and we now have an adhesive which is polysaccharide based. It's a natural, renewable resource based, using food waste as the feedstock, and this allows you to switch off the adhesion and basically allow us to recycle the components. That's gone to full-scale trials now on the plant and shelf, not so far from here. We're very excited about this project, and there's an example in our exhibition, a small example. We've now made full carpet tiles and all sorts of things. And it works. And by the way, keeping into the green chemistry spirit, it's not just about recycling at the end, it also acts as its own flame retardant. Otherwise, typical carpet tiles have all sorts of additives. Never forget the additives. Even the plastic bag is full of additives, colorants, stabilizers. In the case of lots of things, like the chairs you're sitting on, flame retardants. Those flame retardants, I can almost guarantee you in those chairs, are brominated flame retardants, which are persistent in the environment and bioaccumulate. They are definitely no-nos as far as I'm concerned. They should be replaced. The starch technology we have here acts as its own flame retardant. You don't need to add these things. Never forget the additives. It's often people ignore the additives, but they can often be the biggest problem. And that's what we can do now. And here's another one working with B&Q. B&Q, another very inspirational CEO who's driving his company towards sustainability. And the approach there was to say, how can we make future furniture boards, or the things this table's made of, from genuinely green and renewable resources? It's not enough just to say it's made out of straw, because the chances are they've probably stuck the straw together with something very non-green and non-sustainable. Our approach was to make sure everything in there was green and sustainable. So we are using straws and grasses and various other things as well, but we're also using, for example, when you burn biomass, which the power stations, of course, are beginning to do in very large quantities, which is another story I could tell you about, but anyway, they make ashes. What do you do with those ashes? Well, we extract the goodies out of the ashes and use them as adhesives. Never give up. There's no such thing as waste as far as I'm concerned. There's always some value for what you've got left. It's just a question of being clever enough to think of it. So, green chemistry around the UK. The good news is there's lots of green chemistry. The sort of stuff I'm talking about is going on in the UK in ever larger numbers. And I've got the UK here. I should have a world map, really, because I tend to look at things much more internationally these days, and we have to. We're in a small island, you know, in a part of the world which actually is a bit old. And, you know, we're being overtaken very quickly by most of the world. We have to somehow learn how to live with this and what do we have to offer that's exciting and good. And I think the science and technology is still very important, and people still value that. So green chemistry going on in many places around the UK, including, of course, where I am in York, and where we work on research, industrial collaboration, education, and networking. I'll just briefly go through some stuff around education, and there's more on our exhibition stand, as I said before. So we have a master's course, which is very successful. And in my group the other day, we went around the group, not just the master's students, the PhD students, the staff, and so on. And we have 70 people, 19 different countries. And it's wonderful. And, you know, they blend together so perfectly. I always say to them, I said, I could bring a Martian in here and he wouldn't blink. You know, whatever, it doesn't really matter. We have people coming from all over the world, and they're all coming because they believe that we could do things better. We could do things greener and more sustainable. So that's wonderful. And this is, let's skip ahead one. And this is basically looking at it from an HE sector point of view. And we can see other master's courses in green chemistry popping up in places like Imperial, Leicester in the UK, Patras in Greece started this year, which is great, Zaragoza in Spain, Strasbourg in France, Chambéry in France, and hopefully soon in Rio de Janeiro. So there's various places now around the world. This is becoming very international, which is good news. And there's all sorts of other educational initiatives, like Berkeley, California, which I hope to go to next year. They're starting a big green chemistry activity. All sorts of things going on. And there's but they're all bits, you know. That looks good news, but actually that's what, half a dozen? You know, maybe if I allow for a few others in the pipeline, maybe 10 universities in the world with green chemistry courses. How many universities are there in the world? There's a lot more than 10. You know, we have to get the word out far more widely. We have to think about, you know, the content. We have to make sure that the good work that's been done in schools now, you know, the kids coming to us now are naturally thinking about sustainability. And yet they come to universities and we're not very good at continuing that story and building on it, showing them how they can apply this new knowledge they're acquiring into the area of sustainable technology. We have to do that. We have to do that better than we are at the moment. And we have to think about how do we deal with, you know, the way our degree structures are. I mean, I'm an academic. I've been for years. I can say this. The structure of our courses is far too rigid. We are so obsessed with modularization, compartmentalization, protecting key discipline areas and so on. You know, we're missing the big picture. And the trouble is the rest of the world isn't. You know, they are going to overtake us even in education. If they overtake us in education, we have a real problem ahead of us. And there's suggestions that some places like China may well do. We have to find a way to change and this is why what's going on in Bradford is so important. You know, don't underestimate the value of this. It really is. The work that Peter and his colleagues are doing is fundamental to the future of educating our next generation. Whoops. And this is sort of saying, well, actually, you know, guys, you know, there's good reason to do this because there's careers out there. So, you know, our students that do our MSc in green chemistry have no problems getting jobs. They walk into all sorts of interesting areas. One of my guys recently said he was doing carbon footprinting for Sainsbury's store in London. All sorts of interesting applications. Waste management, working for environment agencies, working for consultancies. European Chemical Agency in Helsinki is always looking for new people. Industry now desperately wants people with you know, knowledge about green sustainable chemistry. The retailers are beginning to switch on. We advertised a while ago for the Early Learning Centre. They wanted green chemists. Wonderful, you know. And of course you do. You're using chemicals in your products. You need expert people. And don't just rely on what you read NGOs telling you, because NGOs I work with NGOs, but they can be a little bit extreme at times, you know. You can't rely, you need your own technical in-house expertise to help you make the right decisions. The Green Chemistry Network is something we set up 12 years ago with funding from the Royal Society of Chemistry, and it's got membership, as you can see, all around the world. And that's one of the ways that we actually help to sort of exchange best practice. I'm a great believer in exchanging best practice. So go to Brazil and see what they're doing there with some of their waste streams or not doing. Go to other places. I mean, for example, rice. Rice is think of rice, think of China, think of Vietnam. Actually, the second largest rice producer in the world is Arkansas in the US. You go to Arkansas and they had a huge problem with waste rice hulls. And then they thought, well, why should it be a problem? They work with our local green chemists, and they actually found they could burn the rice hulls to get energy, okay? And then the ashes actually contained carbon, a very nice form of carbon they now sell as a water purification agent. And of course, ideally, they'd also use the rest of the ashes, which are silicate-based, for other applications. So never give up. There's always applications you can find for your waste streams. Well, why aren't the Chinese and the Vietnamese doing that? Well, hopefully we can help exchange best practice. So the world becomes the experiment, you know, in terms of making all this happen. The Green Chemistry and the Consumer Project I mentioned earlier, as I said, M&S, Mike Barry, who's now very senior in the organisation, was only a young lad in short pants when I first met him. He was greatly enthusiastic. We get these people occasionally, and years ago, it was the younger guys in the company wanting to make a difference, and it was fantastic working with them, although, of course, their influence was limited, although Mike's come on very nicely in terms of his work. And others, but nowadays, as I said earlier, CEOs are now saying this as well, which makes it even better. So this is all about trying to make all this understandable to the retailers and the consumers. How do you get the message across? How do I explain to Marks and Spencer, who have no technical knowledge in-house really, about this? This was the challenge we faced, and this is what we're doing by making it low-tech, but making them understand that there are really exciting discoveries out there looking for application. And here's some of our guys, and Elisa's up there. You'll see around the exhibition if you haven't seen her already. And you can see similar things on our stand, not quite as elegant as that, I'm afraid. The weather prevented us from bringing as much as we'd like to have brought to this, but anyway, you'll get some ideas about this. And the nice thing is, I mean, those are some of our people there. Actually, I'll be very sexist here and make the comment that somebody came back from one of these exhibitions and said, oh, I see James's angels were out. And I thought, well, that's okay. And it's great because, you know, the enthusiasm of these people is fantastic. You know, they really believe in what they're doing, and that's wonderful. And they're just some of many, you know, who are now falling into this category. And this shows you basically our wonderful mascot. So you'll see our mascot later. So there's a little one here, and you could take one away with you. This is our mascot, Fabs the Frog. And Fabs the Frog occasionally turns into human form. So in fact, that's not Elisa. She hasn't agreed to wear the costume yet, but she will. That's Jenny, who's another one of those very enthusiastic people in our group, and Jenny's in the frog. And now, Fabs the Frog is a very smart frog. He was educated at Oxford. You can tell he always wears a tie. He wears his safety specs, of course. He's a very safe frog. And he's there to help kids understand, people, not just kids, everybody understand what this is all about. So we have this designed by help with Boots. Boots, the chemist, worked with us to design these so-called ad card machine type things you'll have seen in Boots, and modify them to make them suitable for stories. And I think we have an example of this on our computer in the exhibition. The full stand you'll often see in science centres and so on. And this is what you'll see on the website. It's all about, for example, make your own bubble bath. And what does bubble bath? Why does bubble bath contain chemicals? What are they there for? And that's an interesting question. Even I don't know the answer to some of it, by the way. There's some chemicals in bubble bath, shampoo, and so on, which don't make sense to me. But anyway, whatever. That's another story. But anyway, it helps them to understand the key chemicals and the sustainability